So Zeke, what are you working on there?
Holes.
Holes for what?
A helical antenna.
A helical antenna? What's neat about a helical antenna?
It's circularly polarized.
Okay, what does circularly polarized mean?
It means that it's in the horizontally and vertically polarized.
Oh, neat. So it doesn't matter if you're talking to somebody in a horizontal or vertical polarization, it'll work for both?
Yes, but it will not work for different helical antenna wound in the opposite direction.
So clockwise and counterclockwise matters?
Yes.
Interesting. Okay. So what are you drilling holes in? What's this going to be?
This is going to be the center hole.
Okay. And what are these holes you're drilling? What's going to go into them?
These things!
Wow.
Dowels.
Okay. And what are they going to be used for?
They're going to be used for supports that come off of this.
Okay. Well, great. We'll check back in a little bit. So you finished drilling these. What have you got?
This is where all these will go. For example, this one. They'll go in like this. Get to the door.
Okay. There's
This.
I'll hold this one.
This one. And then there'll be one here. There'll be one here. And one here.
Okay. And they're just going to go all the way around like that. And so
Do
that's.
they have to be that long, Zeke?
No.
So how long do they need to be?
I don't know. He did the math, and I don't know how long that is.
Well, what does the circumference need to be on the circle?
Circumference is 2 meters.
Yeah, right. So 2 meters divided by pi. It's about 0.66 meters corner to corner. So we'll shorten these. I started making a jig for measuring. And so what are we going to do once we get all these on here?
Once we get all these.
Once we get all the support segments glued on, what are we going to do?
We're gonna put on more.
Well, okay, but once we have them all on, what will we do?
We will start wrapping the wire.
Okay, and so it'll spiral along these so it goes to one to the next?
Yeah.
Now you have to glue those in?
Yeah. What are we going to glue them with? Alright.
I see.
So I noticed here, Zeke, look, if we turn this, you can sort of see the spiral there, there.
Turn it really fast.
Turn it really fast, it's like a barber pole.
Cool.
Just attach the drill to it.
Mm-hmm. So what are we going to do next?
We're gonna glue them in.
Glue them in? Well, first, they're a little long, right? What do we have to do first?
Cut them.
Yeah, we'll have to measure them and cut them. So we're working on that, and then we can glue them in. And tell me again, what's this antenna called?
A helical.
Well, Zeke, what do we set up here?
A jig.
What's this jig for?
Cutting these things.
Well, why would we set up a jig?
So that we can get exactly 33.4 centimeters.
Okay, over and over and over and over again for like 60 holes or something?
Yeah.
So how does it work? What's the idea here? How are we going to cut it?
Well, this is going to be plugged in, and I'm going to push the button.
Okay, and then we're just going to line up against this triangle here.
And roll it in.
And roll it in and cut it.
Yeah.
And that way we can always have the same length cut every single time. Huh?
Yeah.
Alright, and then we'll have our cuts the right length to do the holes on the antenna. Great. Well, let's do it.
Okay, so that was one of these things. We're cutting them to put in those holes. Here, we're going to do another one and finish with a stick.
So is the jig helping, Ziki?
Yeah.
What's faster about using the jig?
We don't have to check every time.
We don't have to check, we don't have to measure, we don't have to mark. And look at that. They're all the same length. Ready
Beautiful.
Well, Zeke, what did we just finish?
One of the sides of our helical antenna.
Okay, and so how many sides are there?
3.
3? Okay, so what are these supporting when we're done here?
The wires right there.
Okay, so the wire's going to wrap around these supports. So this is going to be helix shaped when we're done?
Yeah.
Oh, looking forward to seeing it. Let's find out. How's it looking, Zeke?
Pretty good. We finished these.
Okay, so what are these? What are these going to support?
The wire.
All right,
Dad,
so-
how do you get the wire?
Let's get the wire. So this is the wire we'll be putting on.
18 gauge.
18 gauge stranded wire. And we're just gonna, what are we gonna do? Move it around?
We're not gonna loop it around like you might think. We're gonna take this, like do something, and then we're gonna put it on next one, and we'll loop it all around.
Sounds like a plan. Well, let's see how we can do it. This looks a lot different. Ziggy, what changed? Be specific.
This changed and all this wire changed.
Okay, and why is this wire all rolled around this thing?
Because it's a helix antenna.
Okay. Well, is the form of the helix starting to take shape? I mean, obviously this isn't very solid. Is there anything that's actually connected here?
Yeah, these.
Oh, I see. So maybe we can see a circle forming. So is there a circle forming, Ziki?
Yeah, right here.
Oh, you can see it. You can see the spiral really starting to take shape. So this is going to spiral like that all the way down, huh?
And this is our first antenna that is not a dipole.
Oh, an interesting point. Yeah, this is a kind of like an end fed, I suppose. And how is it that we put this spool on? Did we wrap the wire around?
No.
How do we do it?
Well, we just took this and did this.
So we're like taking the spool off and we're sort of screwing it on
Yeah.
to the tube so it keeps its round shape. Well, Ziki, when our last video we were talking about wrapping this up. How'd we do?
You finished.
We finished. It's all wrapped up.
Uh-huh.
So what do we have to do? What did we learn in this process?
Yeah, what did we learn?
What's one thing we learned? How did we have it set up originally? Was it hanging from strings?
No.
What did we have it on?
We had it on strings.
Well, we had it on chairs
Oh, well,
first.
yeah.
And then we figured out the chairs were in the way. And then we put it on strings, but then as we started wrapping it up, the strings we just had going off with a V shape. And they got in the way of these things, so we had to make it vertical. Right?
And then we had to use bicycle hooks.
To hold it up so that we can turn it. And as we turn it, what happens? What happens to the hooks?
Well, let's demonstrate. It does that.
Uh-huh.
Let's go a little more.
Okay. Oh, there we go. The hook
Stops it.
stops it. Why is that? What's causing that?
This is on the opposite side of the screen.
Yeah, well, how did that happen? We were just turning it in a circle.
This didn't move.
Oh, it's like a screw.
Yeah.
I see.
Then we have it happen in several different places.
Okay.
Like,
So, it rotates like a corkscrew.
yeah.
So, as we were working on it and rotating it to add wire, and we just kept spooling wire off the roll here, it kept sliding down our hooks. We kept having to slide them over and pick them up and move them because every time we'd rotate it, they'd be somewhere else.
Yeah.
Well, what do we need to do next?
Check it with our checker.
How does that checker work?
Well, here's how it works. For demonstration, you take this here, put it on there, and this is actually a pretty good one.
Okay. And
And then when we're done with that, we write G-O-O-D and very small.
it had to be very small letters to fit on that wire, wouldn't it? All right. So what's special about the checker? Did we have to build this?
Yeah, I thought it.
So you saw the point, and also why is there a hook at the bottom?
So it can do this.
I see. So it's the right length for these.
Yeah.
Okay. And what's this hook here?
Oh, this is so we can
Oh, there we
turn
go.
on things. And then I plan to turn this into a hammer
Oh, okay.
when we're done.
Could be an interesting hammer.
Yeah.
All right. So what do we have left to do?
Well, check.
Check. Okay, Ziggy, it looks like we're building a chicken coop. Is that what we're doing?
No.
Oh, well, what's this chicken wire for?
This is for the reflector for the thing that was in the last video.
Okay, so the helical antenna needs a reflector. Why does a helical antenna need a reflector?
It radiates in both directions.
Okay, so if you put a reflector on one side, what's that going to do?
It's going to make it all go in one direction.
So anything that would radiate back will bounce forward?
Yeah.
Okay. Well, so we'll have to finish forming this up. And how big does it have to be?
2 meters by 2 meters.
So 2 meters is a pretty big reflector. Why does it need to be that size?
To reflect.
To reflect for the 2 meter band?
Yeah.
Okay. Well, let's keep going and see what we come up with. So what do we have here, Z?
This is a mask.
Okay, and tell me about the mask. Why is it there?
It's there to help support the PVC because it's bendy.
It's bendy. And you know what? We measured this. What do we have to do when we measured it to figure out how much weight it was going to do?
Well, we weighed it with a tiny scale. It's 5 pounds, and this thing, the reflector, which you may not be able to see, is 3.37.
Okay. So when we put the reflector on the other end, what's that going to do to the weight distribution?
Well, it's going to move it that way.
Okay. Well, is that why this isn't centered?
Yeah.
Got it. Okay. So how did we figure out the percentage of distance? Because we know, just conceptually, we added weight to here, and we had to figure out, based on the weight there and the weight here, where do we move the post so that when this weight equals that weight, then it's balanced, right?
Mm-hmm.
Yeah. So why don't you show them the reflector?
Well, this is the reflector. This is what it looks like. It is huge. It is 2 meters by 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 2 meters.
Why don't you just say it this way?
Okay, it's a circle. I would have said that infinite times if he hadn't saved me. Okay, let's put this back down.
So where's that reflector going to go, Zeke?
It's gonna go here.
Okay, so we have this big 2 meter circle on the reflector.
Yeah.
Okay, so why is this reflector a circle?
Because the waves go in circular formation.
So, like, I'm thinking of the Yagi antenna. It has a flat reflector, and it's it's still half wavelength or so. But why is it flat and this has to be round?
Well, this has to be round because the waves are going circularly polarized and not just flat.
Oh, I see. So they could be coming back at any angle, and so they need to bounce off no matter how they're oriented. Okay, very good.
In this picture, Eric is making sure that all of the wire is curved and is looking good for when we put it in the air and we get a circularly polarized signal out into the airspace. Now I am struggling to carry a heat gun and a hot glue gun while Eric is staring into the camera saying, "What is he doing?" All the while, I am getting all tangled up in the wires from the hot glue gun. And some more pictures of me stumbling along, getting all tangled up in the wires. Finally, I decide to drop the hot glue gun and keep the heat gun, all the while Eric is tightening down the mast strings. Now, Eric is looking down the length of the antenna to make sure everything is looking nice and straight and lined up. Now he walks away. And now we are making sure that the wire is curved on all of the sides of the antenna. Now, Eric looks off into the distance, very proud with himself. Now, a change in the scene and direction. Ezekiel Wheeler starts to go into the funny side of his imagination and starts to type hello and starts to make a very important calculation on the calculator. Although he's probably just saying, "Hello, Daddy, can I take the red car to the restaurant?" While Eric is tightening down the rotor, Zeke is making a very important calculation to make sure everything lines up perfectly. Thanks for watching!